So for today in this video, concentrate on the first Newton's law, second Newton's law, and third Newton's law. So the first thing that we need to do here is with this question which has been given. That's saying that the diagram below shows the four forces acting in the ball. So that's the question, and the questions are: the mass of the ball is 0.5 kgs. What are they saying? They're saying calculate the resultant force on the ball. So they're saying you have to calculate the resultant force on the what? On the ball. So the first thing that you need to do in this situation is that you need to calculate the summation of the forces in the x-axis, again the summation of the forces in the y-axis. So how do you do that one? You have to say that summation of the forces in the what? X-axis is equal to, so we have the forces in that element that are going in the x-axis. So the forces that are going in the x-axis, we have 20 newtons that is moving to the negative direction, and 5 newtons is going to the positive direction. So it will be 5, which is the positive, like that, 5 newton, which is the positive, then 20, it will be plus 20 here, right, which is in the negative direction, like that. So what you will have, we have negative what? Negative 15 newtons. So those are the forces, or the summation of the forces in the what? In the x-axis. So how about the summation of the forces in the y-axis? What you do, you say summation of the forces in the y-axis, then you have the 10 newtons which is going to the positive direction, and the 5 which is going to the negative direction. So you have to say positive 10 here, newtons, plus minus, which is going to the negative side, like that. So you find your answer to be 5 newtons. So meaning that your resultant force will be, this is your resultant force, right? So your resultant force in this situation will be what? Will be negative 15 newtons, 5 newtons, like that. So this is your resultant force. So if you want to make this into the, you're putting this into the unit vector form, meaning it will be negative 15 here, I plus 5j, like that. So this is how you calculate your what? Your first question. So let's go on the next question. They're saying the acceleration of the what? Of the ball. So in this situation, they're asking us to calculate the what? The acceleration of the ball. So how are we going to find that? Remember that the force is equal to mass times acceleration. So what's the resultant force, the one that you found? The resultant force is the one that you found. Let's say we found is negative 15I plus 5j, like that. So meaning that this force is the one that you'll be placing here. So it will be negative 15I plus 5j. So what was the mass that is given in the equation? The mass in the equation they have given us to be 0.5. Remember what we're calculating? We're calculating the what? Acceleration. So meaning that we need to make A to be the subject to the formula, such that we end up to have 0.5 into 30. It will give us what? 0.5 into 15 to give us 30i. Then 0.5 into 5, it will give us what? It will give us a 10j, such that you have this. So meaning that your acceleration, you have negative 30i plus 10j, like this. So this is your acceleration. So it means that you have answered the second question. It says the acceleration of what? Of the ball. So this is how we answer question 1 and 2. Now let's go on question 3. What are they saying in question 3? So when you go on question 3, what are they saying? On question 3, they're saying that the magnitude of the acceleration. So what are the acceleration that you have found? You have found that the acceleration is negative 30 here, I plus here, then 10j. So this is the acceleration that you have found. Now they're saying the magnitude of the acceleration. So how do you find that the magnitude of the acceleration? In this situation, that's where I have to say what? The magnitude is equal to x squared y squared. So what was the acceleration in the x-axis? It was 30 squared. How about in the one? It is 10. Then you find your answer, right? So what is the, this is it, 900 plus 100. Then you end up to have 10,000. So what is the 10,000, the square root of 10,000? Meaning that we have to find the square root of 10,000. When you find the square root of 10,000, which is 10,000, give us 100. It will give us 100. Yeah. Oh, wait, not 10,000. Because that's 900. So 900 plus that, it will give us what? It will give us 1,000 like this. So what's the square root of 1,000? You find that the square root of 1,000 is 31.6 meters. Squared. So that's how we find that one. Then the next question, they're asking us to calculate the what? They're saying the direction of movement of the ball. So that's where you have to say theta is equal to tan inverse of 1 over x, like that. So tan inverse, what's x? X, what's y? It's 10 over 8. Then we'll come up to have what? 19.3 meters. So this one is not your theta, because they're saying that on the coordinates is saying this one is negative and this one is positive. So meaning that that's not your theta. Remember, where are those coordinates? The height is negative and the other one is positive. So meaning that the coordinates, we have positive, or we have negative in the y-axis and positive in the x-axis. So meaning that it is under second quadrant. So if it's in the second quadrant, meaning it's supposed to be what? You have to say 180 minus what? 18.3. So you have to find the answer 161.57 degrees. So that's how you answer such type of the question. Now let's go to another type of the question, which is saying a 0.400 kg saucer ball is kicked across the field by a player. It undergoes acceleration by, this is the acceleration, which is A is equal to 3.00 r plus 7.0 j meters per second. Find the resultant force acting on the ball. So meaning that what are we looking for? We are calculating the what? The resultant force that is acting on the ball. So what's the mass in this situation? The mass in this situation, if I find 0.4 like that, then what's the acceleration? The acceleration we've been given, which is that that's 3.00 plus, this is r, plus what? 7.0 j, like that. So you have something like 0.4 times 3, it will give us 1.2 I, plus then 0.4 times 7, it will give us, that is 2.8 j. So this is your what? This is your resultant force. Then the next part, it's question 2. What are they saying in question 2? They're saying that you need to calculate what? The magnitude and the direction of the resultant. So how are you going to supposed to do that one? So in that one, you have to say, remember that the magnitude, well, the force is in the x-axis, like that, and the force is in the y-axis, like that, such that you end up, what's the force there? We have 1.2 squared plus 2.8 squared, like that. Then you end up to have something like 9.28. Then what will be your answer? Your answer will be 3.04. So that's your force, in short. That's your force, or the magnitude. So how about the direction? The direction that you have to say tan inverse of y over x. So tan inverse, what's y? The y is the force. The force of y, what's y? That's 2.8 over 1.2. So meaning that your angle will be 66.80 second square, like that. So that's how you calculate this type of the question. Let's go on to another type of the question, which says a hook plank having the mass of 0.30 kg slides on the frictionless horizontal surface of the ice. Then two hand stick strike the plank simultaneously, exerting the force of the plank as shown. The F1 has the magnitude of 5.0 newtons and it is directed at an angle of 20. So below the x-axis, the force F2 has the magnitude of 8.0 newtons its direction is 0, is theta, is equal to 30 above the x-axis. Determine both the magnitude and the direction of the Planck's acceleration. So in this situation, what are you supposed to do there? What are you looking for? You're looking for the magnitude and the direction of the Planck acceleration. So that's the thing that we're looking for. So in this situation, we have to first to find the forces that are acting on this object. Remember that there are forces that are acting in the x-axis, again in the y-axis. So meaning that we have to do the same thing. Let's calculate the forces in the x-axis, the summation of the forces in the x-axis, which is F1 cos theta plus F2 cos what? Cos theta. Then what's the force of F1? That's 5.0 here, then cos, right? So this is where F1 is, it's below the x-axis. So meaning that if it's below the x-axis, it should be what? 360 minus 20. Then what will happen, it will be 340. So this is 340 plus, how about F2? F2, it's 8.0 cos what? Then cos what? Cos 60 there. Then after you have calculated everything there, you will get something like 8.69 newtons. So these are the forces in the x-axis. Also, let's do the forces in the what? In the y-axis. Just by doing the same thing, which is supposed to be F1 here sine theta plus F2 sine theta. So what are you going to result in? You will result in to have what's F1? F1, remember, it's a 5.0 sine 340 here plus what's the next one? That is 8.0 sine what? Sine 60, like that. Then from there now, after calculating that, you have to get something like 5.21. So this is the force in the y, and this is the force in the x. So if here this is the force in the x and this is the force in the y. Now what really are we asking us? They're asking us to determine both the magnitude and the direction of the what? Planck's acceleration. Meaning that here we're looking for acceleration, right? So what you do here is say forces, resultant forces. We have 8.698 I plus 5.218 J. We're doing this in order of putting this in a unit vector method. So we have gotten 8. This one, we have gotten this one, and this one. So we have gotten this one, which is 8.698, and we've also gotten this one, 5.218. We've just put them in a vector form. Remember that I is for x-axis and J is for y-axis. So from there now, we can calculate the what? The acceleration. How do we calculate the acceleration? Remember that we said the acceleration force is equal to ma, like that. So what's the force? The force is 8.698 I plus 5.21. What's the mass? The mass is 0.30 a this side, then 0.30 over 0.30. Such that this and this, they will divide. Then what are you going to have? You have the acceleration. You're going to have the acceleration in this situation. So okay, the acceleration in this situation, we have the acceleration in this situation will have something like so when you divide there, when you divide this one into there, it will give us I'm just want to write somewhere. So this is A. It will give us what? It will give us something like 28.99, which is I. And then after there, it will give us a plus, right? After dividing 0.3 again to 5.21, it will give me 17.40, like that. So those are the acceleration in the y-axis and the acceleration in the x-axis. So from there, what you do, remember that our acceleration, the one that we found, you have found that after you have divided, you find that the acceleration is what? You have say A is equal to what? To 28.99, which is I, plus what? Which is 17.40 J, like that. So this is the acceleration that you have found, right? So if the acceleration, you have found this one, Remember here they're saying the magnitude and the what? The direction. So how are you going to find the magnitude? Just use the formula, right? Which is x squared plus what? Y squared. Then this is 28.99 squared plus 17.40 squared. Then everything we have to get what? We have to get 83.81 meters per second squared. So that's your first answer. The second answer, the same, determine the direction now, right? Remember the direction is theta is equal to tan inverse of y over x, such that it will be tan inverse, what's y? That's 17.40 over 28.99. Then what will be the answer there in this situation? So in this situation, the answer will come out to be 30.97 degrees. So this is how you solve this type of equation. So let's go into another type of equation, which is this question. They're saying that the car has a force acting on it, as shown below. So this is the car which is moving, and there's a forces that are acting at a certain angle like that, right? So if you draw the situation here, you find that the car is going like this and the car is going like this. So we have the angle which is here, which is 30, and also we have the angle which is there, which is what? 10. So what are you supposed to do in this situation? In this situation, we have also to calculate the forces that are acting on this car, which are in the x-axis, again in the what? Y-axis. So let's start with the one in the x-axis, which is fx is equal to f1 cos theta plus f2 cos theta. So in this situation, what are the forces we have? 440 cos. So there in this is here we say 90 minus that, it will give us what? 60. But in this situation we add, so we have to say 90 plus 10. So here we have to say 380 cos 100, like that. So what is the answer when you have done that? You will find the answer such as 159.013. So that is the forces in the x. How about the forces in the y? We also do the same thing with the forces in the y to get f1 sine theta plus f2 sine what? Theta. So meaning that we have 440 sine 60 plus 380 sine what? 100. Then what will be your answer? Your answer will come up to be 763.2938. So that is your answer. Now, after finding the summation of the forces in the x-axis and summation of the forces in the y-axis, then that's when now we can calculate the what? The net force. Since they're saying what's the net force here, right? So meaning that the net force is just they're saying calculating the what? The magnitude. So how are we going to calculate this, the magnitude? Remember it's x squared there plus y squared. Then what is the x? The x we have already know that is 159.013 square there plus 763.93 square. What will be your answer? Your answer after calculating all of these, you have to get what is what? 780.13 newtons. So that is your first answer, which is here. So the first answer which is here to what? On the newtons it will be, on the net it will be 780.31 newtons. So what about the next question? So the next question, it says what's the acceleration of the car? So in this situation, how are you supposed to find that the acceleration of the car? So the acceleration of the car, we find it like this. We say the F is equal to mass times acceleration. What's the force? The force is 780 here, 0.31. What's the mass of the car? The mass of the car is 1000 A. So here, what are you calculating? We're just calculating the value of what? Of A, the acceleration, which is 780 divided by 1000. 780 divided by 1000. The answer will be 0.78.031 meters per second squared. So that's how you calculate that type of the situation. Let's go into another type of the situation, which is this type. So in this type here, what will are they asking you? They're saying that a farmer is lifting some moderate heavy rocks from a field to plant crops. He lifts a stone that weighs 150 newtons. What is the acceleration of the stone if the farmer applies a force over that? So here in this situation, remember, we have this stone here. Let's put it as this as a stone, and it's weighing, what's the mass of this stone? It's weighing 180, right? To carry this, in short, it's weighing 180. So it's weighing this stone here, which is here, it's weighing a mass of 180, right? That's the mass that this stone is weighing. So that's 180, right? Newtons. So they're saying that he's trying to push this stone by the force of 230. So they're saying what acceleration of the stone if the farmer applies the force of 230 there. So the first thing here, remember that we know that force is equal to ma. Now the force that was being applied we have, and but the only problem, we don't have the mass. So what are you supposed to do? Let's calculate the what? The mass. Right? How do you calculate the mass? You say the force is equal to m times the gravitation. So here to be 180 is equal to m here, and the gravitation, that is 8 1, like that. Let's find the value of mass, which is this and this, to divide. Then what will be the answer there? When you divide there, when you divide here, it will give you 50 kgs, like that. So for you to calculate the amount of how this stone was accelerating, what are you supposed to do in this situation? You have to say the force applied minus the force of the stone, which is ma here. What's the force that was applied? That is 230 minus what? 180. What's the mass? It will be 50, like this. So what are you supposed to do there? In this situation, we say 230 minus 180. So what's the answer? 230. Oh, sorry. Here is not straight. This is not. When you divide there, it will give you. When you divide there, it will give you 18 point. 18 point what? 18.35 kgs. So this is 18. To give us 18.35. Then you divide by, so that you can find the value of acceleration. This and this, you divide. What will be the answer? Here on top, to be 50. Divide by what? 18.35. Then it will be 50. 50 divided by 18.5. That's 18. 50 divided by 18.35. Then your answer, you get 2.72 meters per second squared. So this is how you calculate this.